Hey, how charged is it? I don't know how long it takes.
It's like, I don't think, oh no.
All right. All right, so we're in our notes. We're ready to start section 1.4, which for most people is kind of easy. Let's see if you agree. All right.
I know.
Guys, I know we had kind of an unusual day, but it's time now to get focused. Okay? So, question A says add the F function and the G function. This should not be confusing. The F function is 3x plus 2, and the G function is x squared minus 1, and I'm simply going to add them. So my answer is going to be x squared plus 3x plus 1, if I collect right terms and put things in descending order. What do you think h minus f means? H minus f. Now, you do have to be careful, because if you are subtracting f, f is a quantity, so I'm going to have to distribute that negative. Negative x minus 2. Right? Oh, we'll come back and do the domains in a minute. F of x times g of x. Well, I'm just multiplying them. So that'll be 3x plus 2 times x squared minus 1. So it's going to be a FOIL, right? 3x cubed. Now, when I FOILed, I went a little bit out of order so that these terms would be in order. All right, so H times P is just that. I can't do anything with that.
Oh,
Nice.
And H over F. Now, can I cancel anything in here? Very good, you can. The only way you can cancel in 3 parts is if you can cancel out of every part. All right, so everybody okay with that? That seems super simple. Now let's talk about domain. I'm looking at the answers. What's the domain of this guy? Guys, what's the domain of that? Negative infinity to infinity. In other words, all real numbers. Why? Well, okay, so one way to think about it is it's a parabola. Another way to think about it is it does not have a radical and it doesn't have a denominator, so there's nothing to screw it up. All right, what about this one? How about this big little cubing thing? Be careful. What about this guy?
0.
Actually, it can be 0, but it can't be lower than 0. So your domain would be x has to be greater than or equal to 0, which would be bracket 0 to infinity. And what about this guy? Can't be negative 2/3, because 3x plus 2 cannot be 0. So subtract 2 divided by 3. So how will I write that? Negative infinity to negative 2/3, or negative 2. Do I have to separate the
No,
two?
I apologize.
Alright, that's it. So a little bit of review there in that domain stuff. Everybody okay? I'm hot too. There, I put in a, what do you call it? I'll just call it a complaint. Sometimes
We're on the whole school though.
is the whole school hot
Yeah.
now?
The whole school also smells like sewage. Yeah, it's really fun.
They told me they fixed that. I don't know.
No, that's who did they pay?
Alright, next section. P of H of 1. Now, we got some people absent today. You're gonna sit down with them and they'll say, hey, I have a question. Well, what does this mean? And you're gonna say, P of H of 1. That's the way this is read. This is not a multiplication. This is plugging one function into another function. So the first thing we do, you'll recall from last year, is evaluate H of 1. We start right here. That shouldn't confuse you. It's inside a bracket, inside parentheses. That's where we start. So, oh, I erased some of my functions. What's H of 1? H of 1 is 2. Now I take that answer, H of 1, this is 2. So now I'm finding P of 2. And P of 2 would be the square root of 2?
Yeah.
And that's the answer to the question. So this is a two-step problem. You find an answer, and then you take that answer and plug it into the next function. You like?
Never mind.
Now, did you use this notation last year? That's a little tiny open circle, and it actually is another way of writing this very same problem. This means the same as this. Oops. Don't be confused by the notation, okay? That little open circle is called of. So H of F of 2. So what do we start with? F of 2. And what do we get when we do F of 2? 8?
Yeah.
Everybody get 8? Mm-hmm. Now, we're not done. That's F of 2. So now we have to take the 8 and plug it into H. So H of 8 is 16. And that's my final answer. Now, what about this next one? What's missing? A number. So we're going to have to do this one in terms of x. So H of F of x. So in light of what we just did, didn't we take F of 2 and plug that into H? So we're going to take F of x and plug it into H. So don't be alarmed. F of x is 3x plus 2. So I'm going to take that thing right there, that's F of x, and I'm going to plug it into H. So 2 times 3x plus 2, or 6x plus 4. You okay with that? Okay. FG. As crazy as it might sound, that's another notation for the same thing. That means f of g of x. All these things mean exactly the same thing. Sometimes we just get lazy and leave off the x, but it all means the same. So what do we do first here? We have to find f of g of x. Then what are we gonna do? We're gonna take g of x, which I don't have written down. And what are we gonna do with g of x? You're not multiplying it, you're taking it and plugging it into f. So there's my f. So I'm gonna take this guy right here, and I'm gonna plug him in right here. Because when I do a function, I plug in whatever for the x. So I'm gonna have 3 times x squared minus 1 plus 2. So FG means f of g of x. So I take my g of x, which is this, and plug it into my f. So did you get 3x squared minus 1 as your answer? Everybody okay with that? All right, now, the next section is, we're shifting gears here. The next section has to do with what are called implicit functions. Now, here's the deal, folks. Anybody know what shape this is right here? You should know, we talked about it earlier in the year. It's a circle. It's a circle centered at the origin with a radius of 5, not 25, 5. Now, is that a function? No, that's not a function. How come? Doesn't pass the vertical line test. So, how am I going to graph that on my calculator? Well, you're going to have to graph it as 2 separate parts. If I could somehow graph the top half of the circle, would that be a function?
Yes.
And then if I could also graph the bottom half of the circle, would that piece be a function?
Yes.
Okay, so the top half and the bottom half are called the implicit functions. They are the little functions that make up this big shape. All right? To find those, it's very, very simple. We simply go back to our original equation and get y by itself. Okay? So here we go. We're going to get y by itself. Finn, we're not graphing right now. We're getting y by itself. So y squared equals 25 minus x squared. How would I get y by itself? Square root. And you guys, remember when you square root, it's got to be plus or minus? Always. So you're going to get 2 equations. You're going to get the positive one, which is the top half of your circle, and you're going to get the negative one, which is the bottom half of the circle. All right, so we don't have much time. Type these in on your calculator. I don't know how your window is set. Go ahead and do, just go zoom 6, get a standard window, and type these in. By the way, while you're typing them in, listen to me. This does not simplify. If you try to simplify that, you will be wrong. This does not simplify. You cannot break apart a radical if it has a minus or a plus in it. So that's it. These are the implicit functions. These are the answers. So positive square root, 25 minus x squared, negative, and make sure you're using your negative, guys, not your minus. Make sure you're using your negative down here, but your minus in there. Tell me what you got. Did you get something that looked like this? Now, the problem, what did you say, Robbie? It's more of an oval, right? Now, it's supposed to be a circle. I promise. Here's what I need for you to understand. when we set up our look at your screen. Isn't your screen rectangular?
Yeah.
So when you do a regular standard window, you go from -10 to 10 and -10 to 10. I mean, that's what we do. There's nothing wrong with it. But in here there are 10 hash marks. 10 hash marks. Does it make sense to you that because the screen itself is longer this way, that these hash marks, these 10 hash marks, will be more spread apart than these 10 hash marks? So what that means is every picture you've ever graphed has been pulled this way because your screen's rectangular.
So can we change the
You can fix it. Go to zoom.
What?
And I think it's option 5, but I can't swear by it, there's a square.
Oh, yeah.
Zoom square. And what zoom square will do is square the screen. Now, can you zoom square every picture you do? Yes. You don't have to do every one, obviously, but every time you do it, it will. Now, listen. Did your pieces quite connect?
No.
Don't worry about it. They're supposed to. I do not have the answer to that question. I don't know why they don't. Sometimes they don't. I don't know. Assume they do. Okay, the pieces are going to connect. All right. All right. We don't have time to graph anymore, but we're going to go ahead and do the next one. We're going to find our implicit functions. So, just so I don't lose it. These are the answers to the question, kids, right here. Those are the implicit functions. So, if my equation is this, which by the way, is not a circle, how will I find my implicit functions? It's y by itself, and that's going to mean square rooting, and that's going to mean positive 25 minus x square root and negative 25 minus x square root. Those are your implicit functions.
I have a question. So why is it on that side under the radical that the x is squared, but the second time you wrote it, it was just
Okay, look at your two equations. Look at problem A and look at problem B.
Oh, I didn't realize it was on B. I thought it was
No, it does not make a cone.
Like it makes a little like this.
It makes the parabola
Oh, it just looks like it came to a point.
opening to the side.
I want to make it a square.
All right, here we go.
Oh.
Now, guess what shape this is going to be? A V. The difference is what's inside the absolute value. So it's not going to be a V like this, it's going to be a V like this, right? It'll be a sideways V. Is a sideways V either direction? Is that a function? No. So we need to break it down into its implicit functions in order to graph it. Now, this is a little complicated, so I need you to pay attention. First of all, this part's not complicated. You can certainly get y by itself, right? But stop and think about it a minute. If I said the absolute value of y is 3, what could y be? What could this number be if its absolute value is 3? It could be positive or negative. So if I break this down, y can either be that, or y can be the opposite of that. There are your two equations. Those are your two implicit functions. Okay? Come on, we got 2 more to go. Y squared equals x squared. Oh, that's easy. What do you think? Yeah, we're supposed to read that one. Are your two equations x and negative x? Don't let me pull a fast one, but there's really no other work to do, right? I just square root both sides. So what does that look like if I'm not gonna go after my calculator, that's your identity. What's that? Same thing, other direction. So this graph is nothing but a big old X. And the last one. Can I rearrange things and write it that way? Is that the same thing? Not trying to confuse you, just don't want to mess with the negative. Is that the same thing?
I don't think so.
Yes, it is.
It is?
Yeah. Subtract the 1, add the absolute value.
Okay. Could you not like move the X over and then divide by negative 1?
And this is exactly what you're going to get.
I have a question. So if you subtract the negative 1 over,
Oh yeah, it is. It is. It was just backwards.
no, yeah, there's a subtraction sign between the.
Okay, never mind. This is right, but if you need to do it this way, absolutely do it this way.
I just ordered.
Isn't that the same as X minus 1? Yes. Okay, take my word for it, I can do my arithmetic, but it's okay. This is where I'm at. Now, what are my implicit functions then for this? Either y equals x minus 1 or y equals negative x plus 1. Now, I need to warn you. When you grab one of these shapes, they're lines, and they both, well, they're lines and they cross somewhere, right? When you draw these lines, one has a positive slope, and one has a negative slope. Okay, so when I draw these lines, I get an X. But what did I say this shape was supposed to be? It's supposed to be a V. So the V hinges on this point right here. The V is either this V or this V, and you gotta decide which one it is. Any ideas how we might decide whether we need to keep this V or this V for this equation? Any ideas how we might decide? Well, how about if we pick a point? Wait a second. How about if we put in 2? If we put in positive 2, don't we get positive 1? So this is the part of the V we want to do. All right. We're almost done. Next time we'll finish 1.4, so if you want to go ahead and start that homework, do it. We will also start reviewing for a test next time.